Welcome to LNP Renewable System Integrator. Today we're going to discuss some of the basics of electric vehicle part 21. So this session we had classified into 25 parts. If you have missed anything, no issue, please subscribe to the channel. In our channel we had created a playlist. In the playlist you can be able to watch all the 25 parts. So in our discussions we will be using so many abbreviations. So if you have any doubts, you can refer these abbreviations for your clarity. What are the things that we are going to discuss in this part? So we are going to discuss what are the components inside an AC charging station and how our AC charger looks like, and what are the Indian standards followed for AC charging system for the electric vehicles, and what are the components inside a DC charging station of an electric vehicle, and how a DC charger looks like, and what are the Indian standards followed for DC charging system, and what will be inside 3.3 kilowatt charging station. So this is a block diagram of a AC charging station. As you can see, in an AC charging station, so we will have a AC to DC converter, we will have a system controller, we will have a vehicle communication, and we will have a HMI and the external communication. Okay, apart from it, we used to have a current and voltage monitoring features. We also will have a AC power relays, and at last we will have a interfacing module to interface with the station and the vehicle. Okay, and most importantly, in our vehicle also we will have a pilot. So through the pilot only the communication is getting established between the charging station and the vehicle. So this is one of the example of Delta Electronics. It's from Taiwan. So for 7 kilowatt to 22 kilowatt, this much different types of chargers, AC chargers we can use. So in our block diagram we can see current and the voltage monitoring. Okay, so it monitors the power transfer to the vehicle. Okay, and what is the use of this AC power relay? So it makes or breaks the connection with the electric vehicle based on the discretion of the host controller. Okay, and we'll have a vehicle interface. It controls a pilot signal coming out of the controller and serves as a handshake between a electric vehicle and electric vehicle supply equipments. Okay, and we have a AC to DC converter. So it converts the AC power into DC power whenever necessary. We have a system controller. It has a microcontroller. It manages all the services. And we have a vehicle communication module where CAN is there. That is controller area network, or RS for communication, or Ethernet to communicate with the electrical vehicles. And we have a HMI which improves the user experience, which provides the visual status updates. So when we get into the Indian standard for AC charging, so we should follow the IS 17017 part 1 standard, which provides the basic feature of all electrical vehicle stations. And also in part 2, both AC and the DC electrical supply equipments needs to conform to the technical standards IS 1701 part 21 and 22. So when we get into the standards, say for example you have a single phase supply which is rated up to 15 amps. So we have 6 different types of cable, that is A, B, C, D, E and F. So it describes how, because in a type A cable we will have a electrical supply equipment which will be connected to the power converter, and the power converter it will be connected to the electric vehicle. Whereas in case of cable B, we will have an electric vehicle supply equipment directly connected to the electric vehicle. And in the cable type 3, it is already getting connected to the electric vehicle supply equipment. And in the cable D, we will have an electric vehicle supply equipment connected to the electric vehicle. And cable E, it is already attached to the electric vehicle supply equipment, same like petrol stations we have the cables. Okay, and the cable EF, it is an extension cable for D to connect with the electric vehicles. So using cable E, we can do slow charging. B and C also used for slow charging. But using cable D, E and F, we can do AC fast chargings. Okay, this is an example of a female connector IEC 60309 which is being used for charging. And if you go for IEC 60309, this is how the male connector looks like. So when we get into the output options for the first one, we have an electric vehicle without an onboard charger. So this is how it looks like. Okay, since if there is no onboard charger, the heaviness will be little less. So we have the second option is that we have an electric vehicle with the onboard charger. So this is how it looks like. So through the IEC 60 female code, we will get connected to the male. Through the male, we are trying to connect with the vehicle connectors. Next, the third option is that we have a cable attached to the electric vehicle supply equipment which will be used for slow charging. So maximum important constraints we have when we go for AC cables, its maximum length can be from 1 meters for if it is a type E cable. If it is a type C and D, we can use up to 7.5 meters. The rated voltage can be 3 phase, that is 415 volt. Okay, maximum 63 amps current also we can use. And IP rating is very much important. It should be IP44. So we're going for a 3-phase cables. In 3-phase cables up to 63 amps we can use AC interface. In that also we have two options. The first option is we have a detachable cable supply, and the second one is we have a cable supply integrated with the electrical supply equipments. And if you're going for 3-phase 63 amps also, type A, B and C we can use for AC slow charging, and type D, E and F we can use for fast chargings. Okay. So if it is less than 1 kilowatt, we can go for single phase 15 amp supply. If it is greater than 1 kilowatt, so the maximum length will differ. It will be 7.5 meters, and the color of the cable can be orange color, and protected type should be IP44. So in the electric vehicle supply equipments category, based on the load we have different classifications. Say for example, if you have a plan to do slow charging, we can use AC slow A, B, C. So A will be of 1 kilowatt and B will be of 2.2 kilowatt and slow C will be of 3.3 kilowatt. All these three will be of single phase. And if you are planning for a fast, then you have to go for 3-phase supply. So 3-phase supply minimum starts from 10 kilowatt and extends up to 45 kilowatt. Okay, so this is the block diagram of a DC charging system. Inside the DC charging system, we have a AC to DC converter. We also have the same in the AC charging system. We have a system controller. We have a vehicle communication. We have a HMI interface. But extra new thing which is present in the DC charger is that we have a power factor correction, and we also have DC to DC converter. That is, it can also act as a booster. Okay, and also we have the vehicle interface to interface with our vehicle. So when we get into the standard of the DC charging, so it should comply IS 17017 Part 23 standards, and we also have BIS standards which has finalized IS 17017 Part 25, which is specifically providing the low DC power of a less than 7 kilowatt. Then we can follow these standards. So what are the recommended features or a specification for a power converter? First and the foremost thing is that it should comply IS 12360 standards, and it should input frequency can be 50 hertz, and the maximum rated power should be 1.1 kilowatt. It should have a power on indication, it should have a fault indication, and most importantly all the safety features like overload current, short circuit protection, fault detection, okay, over voltage protection, battery reverse, all these features should be there in the converter. Apart from it, in environmental wise, it should withstand from 0 to 55 degree, and IP rating is same as that of electrical supply equipments. So in our block diagram of our DC charging system, we saw something new, that is the power factor correction. So its purpose is to ensure the input current is in phase with the grid voltage. So it improves the grid's overall power factor. Okay, and we have the AC to DC converter, as we all know. So it converts the AC power from the grid and convert it to high voltage DC. And we have a DC to DC booster. Its purpose is to transfer the DC to the electric vehicle. So this is the block diagram of a 3.3 kilowatt charging station. As you can see, we have a EMI filter for the power, which AC power which is coming from the line in neutral, and we have a relay for the protections, and we also have the diode bridge rectifiers. From there it is getting to the auxiliary flyback DC to DC. From there it is moving to the power factor connection stage, and also we have a full bridge DC to DC converter, and we have a diode bridge rectifier which is made up of MOSFETs. So the power factor controlling, we are using power factor controller and a driver. We are communicating with the PFC different stages. And for the phase shifted full bridge, we have a DC to DC converter with isolated gate drivers. Apart from it, we have a microcontroller unit which try to sense the voltage, and it will helps to measure the current. Even we can make the digital isolations. Even for temperature measurement and protection purpose, this microcontroller plays an important role. So this is a detailed view of a 3.3 kilowatt charging station. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We can provide the contact details here. We, LNP Renewable System Integrator, we are providing PLC programming training along with the certification ISO 9000 2018 for Siemens, Allenburg, Delta PLCs. And if you're really interested to work in the GCC countries, then you can contact us. We are providing training in building management system and building automation system. And if you had a plan to put fencing for your agriculture farms, then you can contact us. We are providing solar fencing as a kit. And if you're really interested, okay, to learn about the solar, or if you plan to establish a project like on-grid, off-grid, and hybrid, even for solar, we are providing designing, installation, testing, and commissioning, and consultancy supports also. If you had a plan to learn related to the electric vehicle basics, then you can contact us. We have provided the contact details here. We are providing the training along with the certifications. Thank you so much.